Okay, we're going to identify all the exact solutions to this equation that involves tangent of x. So 2 tangent of x, 2 multiplied by the tangent of x plus 3, quantity, equals 5 plus tangent of x. We want to find all those x's and make true statements here between 0 and 2 pi. So to get going on this, what I'm going to first do is go ahead and distribute this 2 from the outside of our set of parentheses to each term on the inside. So that's going to be 2 multiplied by the tangent of x, plus 2 times 3 is going to give us 6 on the left-hand side there. And then 5 plus the tangent of x. All right, at this point, as I take a look at our problem, I notice that we have tangent of x on both sides. They're both just raised to the first power. There's nothing overly complicated on the inside. So what I'm going to do is I'm going to treat those as though they're our variable. And this is basically a linear equation where I want to get all the variables, all the tangent of x's in our case, to one side first. So let's go ahead and subtract tangent of x from both sides, and that'll move them all to the left-hand side. All right, so we started with 2 tangent of x's. We subtracted 1 away, so we're still going to be left with 1 tangent of x. Let's go ahead and bring down our plus 6. Bring down that 5, and then on the right-hand side, we had tangent of x, but we subtracted tangent of x away, so that leaves us with 0 tangent of x's. All right, the next thing I'm going to do is we've got the tangent of x on, all of those are on one side. Let's get all of the constants to the other side. So in this case, I'm going to subtract 6 from both sides to move that constant away. So now we have tangent of x left on the left-hand side and -1 on the right-hand side. Well, -1 is actually a pretty nice value. All right, let's think about our tangent graph. So a quick graph to go along with this, right? +1 shows up when we think about our handy-dandy table. -1 is also pretty close there. All right, we get +1 and -1 on our graph of tangent. It's halfway in between, basically, if you were to draw this nice graph of tangent. All right, because this is -pi/2 and +pi/2 where we get our vertical asymptotes. Halfway in between there, this is going to be -pi/4 is going to give us that -1. Or we can say tangent of -pi/4 works out to be -1. All right, so that's kind of indicating that x can be -pi/4 based on the graph. However, that doesn't really fly with this interval that we're looking for. All right, only one at x values between 0 and 2 pi. So to account for that, what we can do is go ahead and to the end of this add whatever the period of tangent is. In our case, it's pi multiplied by k, where k is an integer. All right, meaning like a positive or negative whole number could be 0, I suppose. All right, but that's the formula for all of the solutions to this equation. All right, but we only want those solutions between 0 and 2 pi. So if we put a 0 in for k, if k equals 0, we're going to get -pi/4. Doesn't work. So let's next try, what about k equals 1? That's going to give us the solution x equals -pi/4 plus pi times 1, right? Replace 1 in there. Or -pi/4 plus, I'm going to rewrite this as 4pi/4. That's the same thing as 1 pi. I've just strategically rewritten our 1 out in front there. So it's 4/4. So I get a common denominator. With a little bit of combining, we can get 3pi/4. All right, that's a good value. That's between 0 and 2 pi. So I'm going to say, yep, that one works. Are there any more? Well, let's try k equals 2. All right, so in that case, we get x equals -pi/4 plus pi times 2, or that's 2 pi at the end there. Again, just strategically rewrite this. 2 can be rewritten as 8/4. We'll bring our pi along. And now what's going to happen as we combine our numerators, we have -1 pi plus 8 pi makes 7 pi/4, which is, again, just a little bit smaller than 2 pi. So that's a second solution. If we tried k equals 3, we're going to see that our values are bigger than 2 pi. And so it's not going to fit in the correct range of values for x. So I hope this helps out as you're working on these and trying to solve down trigonometric equations.